So tonight's talk, a short introduction to the Thames Estuary. We're delighted to have our speaker, Wanda Bodnar, who approached us and actually said we'll be interested in this talk, and we were really excited and jumped at it. Wanda Bodnar is a chartered marine scientist and has been working at the Thames Estuary Partnership for over 7 years on a number of different projects, such as Fish Migration Roadmap, Blue Connections, Estuary Edges, and the Roadmap to Climate Resilience. So a lot of really interesting work going on there. And just a little bit about the Thames Estuary Partnership. It's a collaborative initiative and it's focused on the sustainable development and management of the Thames Estuary. It's a forum for bringing together a whole range of people, government bodies, local authorities, environmental organisations, businesses and communities to address the challenges and the opportunities that are associated with the Thames Estuary. So I'm going to stop sharing my screen now and I'm going to hand over to Wanda.
Thank you very much. Let me just sort out the technicalities on my end. So I hope you can see that.
Yeah, we've got the thumbnails at the moment. If you want to just go into the slide. Yep, perfect.
All right. And let me just sort out other things on my end. Right. So thank you very much for the introduction and welcome everyone to this short introduction to the Thames Estuary online talk. So just to provide an overview, first I will talk about the tidal movement and the salinity of the Thames Estuary, and also will explain why the Thames has a brown color. Then I will talk about the past, specifically about the effects of the successive ice ages, the arrival of the Romans, the Anglo-Saxon period, the Domesday Book, the Old London Bridge, and about the series of decline and recovery that occurred in the 19th and 20th centuries. Then I will talk about the habitats, the fauna, the issue of plastic pollution, will explain why the Thames is an archaeological site, and will make suggestions on ways of reconnecting with the Thames. Lastly, we'll talk about the future, specifically about the tideway tunnel and the climate emergency. And at the end, there should be 5 or 10 minutes left for questions and answers. So to start off, what we mean by the Thames Estuary. So we should distinguish between the River Thames, which is a 345-kilometer long river rising from a series of springs in the Cotswolds and flows into the North Sea, and the tidal Thames or the Thames Estuary, which is part of the river that is under the influence of the tides. The tidal limit is at Teddington, where a complex of 3 locks and a weir was built for water management purposes in 1810. And of course, because of this connection to the sea, the Thames Estuary has 2 high tides and 2 low tides in a day. This is why London is a coastal city. Apart from the daily tidal movement, there are also the monthly tidal cycles. These are the spring and the neap tides, when the height of the tide will vary depending on the alignment of the moon, the sun, and the earth. So the tidal range of the neap tide is around 3 meters, and the tidal range of the spring tide is about 7 meters. It is during the spring tides when areas such as the Path in Richmond gets naturally flooded. In terms of salinity, the Thames is a well-mixed estuary with salinity gradually increasing towards the sea. However, on average, we can distinguish between freshwater, brackish, and salty areas. In addition to the gravitational forces that govern the tides, we also have to account for the 100 meters height difference between the source of the Thames and where it meets the sea, and for all the larger and smaller rivers that flow into the Thames. So the Thames is the main river that collects other rivers within this area, and this is the area that we call the Thames River Basin. Because of the topography and the tributaries, on average, the outgoing ebb tide lasts slightly longer than the incoming flood tide. So for example, if we were to drop an object somewhere in central London, because of that back and forth movement of the water, it would take about 3 months to reach the sea. Also, because it is a river basin where a series of rivers will carry matter like mudstone, chalk, clay, silt, sand, and gravel downstream, the Thames is a brown river. All that brown color is because of the resuspended and mixed mud that gets carried around by the tides. In fact, the Thames would have been brown already when the Romans arrived, who referred to it as Flumen Thamesis, or dark river. So stepping back in time a little bit, the Thames appeared between 60 to 30 million years ago, and based on geological records, the ice ages of the last 1 million years or so could be reconstructed, and this shows that these ice ages actually influence the position and the flow of the Thames. So from about 800 to 480,000 years ago, the sea level was about 100 meters lower, and the Thames was flowing slightly further north. Then between 480 and 420,000 years ago, when the temperatures dropped, an ice sheet was formed over Northern Europe, and the Thames was slightly diverted to the south, flowing into an ice-dammed lake. Then, when temperatures rose again, water from this ice-dammed lake spilled over and created the Strait of Dover and the Strait of Calais. Between 425 and 130,000 years ago, there was another predominantly cold period. And between 130 and 115,000 years ago, the climate started to warm again, and Britain was completely cut off from mainland Europe. It was this period when the average temperature was about 2 to 3 degrees Celsius higher, and southern England had a tropical climate. A specific example here is Trafalgar Square, where remains of tropical animals were found. Then from about 25 to 13,000 years ago, we had what we call the last ice age, when water levels fell by about 120 meters, and an ice sheet was once again formed over Northern Europe. This was the period when rivers from southern England and northern Europe were flowing into the same river, which was called Channel River, and this is why the aquatic flora and fauna is very similar in these regions. Once this ice sheet melted, the currently known coastline was formed. Right after the last ice age, the marshy floodplain on the Thames was about 4 kilometers wide and was dotted with a system of islands and channels. Making a jump in time, based on archaeological and historical records, this is how London and the Thames would have looked like in 2000 BC. The north bank was a marshy and densely wooded area, and the south bank was a lower lying muddy and marshy floodplain with sand and gravel islands. And again, another jump in time. It was Julius Caesar who first arrived at this area now we call London in 55 BC. Then in 43, Emperor Claudius came back with Roman troops, and they crossed the Thames at a point near where it empties into the ocean and at flood tide forms a lake, and founded Londinium, which was a colonial outpost of the Roman Empire. It was the Romans who built the bridge, possibly not far from the current London Bridge, as part of their road building program to hold conquered areas and allow troops to move swiftly. Apart from this narrow area where the Romans could cross the Thames, the location of the Walbrook River was also important as it acted as a freshwater source. At this time, the tide was probably as little as 1.5 meters in range, with the tidal head estimated to be at the bridge. And this is just to highlight a few familiar place names like Ludgate, Moorgate, and Aldgate, which were locations to enter Londinium. And of course, today, this is the area known as the City of London or the Square Mile. Following the collapse of the Roman Empire, there is a 200 years gap in historical records. It is assumed that Londinium may have been completely deserted. Then the Anglo-Saxons appeared, who were a cultural group who migrated over from mainland Europe, and they established Lundenwic west of Londinium. Later on, Viking raids drove the inhabitants back behind the safe walls of Londinium, and Lundenwic became known as Oldwick or Oldwich as we know it today, which means the old town. During the Anglo-Saxon period, fish was an important part of the diet. A way of harvesting fish was with the use of fish weir, which was a V-shaped structure constructed on the intertidal foreshore. There are remains of fish weirs found at Barn Elms, Putney, Hammersmith, Isleworth, Chelsea, and Nine Elms. The position of the fish weirs at Chelsea and Isleworth gave evidence of the different species that they were used for. The weir at Isleworth faces downstream and could have been used to trap salmon, while the one at Chelsea is facing upstream, which was most likely was used to trap eels. They also used specific eel bogs, which were facing upstream to capture eels during their seaward migration. At this time, eels took up about 50% of the fish biomass in the Thames and were especially favored during Lent as a meat substitute, as people thought that eels were reproducing asexually. Then enter William the Conqueror, the first Norman king of England, who ordered the collation of the Domesday Book. This book recorded the number of households, economic resources, who owned the land, the tax paid for by almost every settlement in England, and a form of payment were eels, especially by fisheries and mill owners. Evidence shows that rent was paid in more than 500,000 eels per year at the time. Eels were usually counted in units called sticks, and 10 sticks of eels was called a bind. Moving on to the story of the old London Bridge. Between 43 and the late 1100s, the bridge that the Romans first built was destroyed and rebuilt a number of times. And so between 1179 and 1209, the old London Bridge was built, which was 8 meters wide, 270 meters long, and it had 19 broad pointed arches and a drawbridge in the middle to allow the passage of tall ships during high tides. The building works were carried out during the summer season, and they used bolts and a pile driving hammer to create the individual bridge footings. Because the bridge had narrow arches and wide piers, it became a partial dam or tidal barrier restricting the flow of the Thames. And as a result, the upstream part of the river often froze over, giving way to the famed Thames frost fairs during the period called Little Ice Age. This is how the bridge looked like over time, and you can see that until the 1700s, which is the bottom image, there were houses and shops on the bridge, and the rent coming in from these properties was used to maintain the bridge itself. And just as an interesting fact, in 1722, it was on this bridge where the keep to the left rule was established for the first time. The traffic coming into the city had to keep to the west or to the left, and the traffic leaving the city had to keep to the east or to the right. During its 600 years of history, natural disasters in the form of fires and cold weather equally caused significant damage to the bridge, and the removal it was discussed in 1789. However, there were some oppositions as there was a fear that the flow of the river would change, and the water would fully ebb away during low tide. In 1821, a committee was appointed by Parliament to consider the building of a new bridge, which was completed in 1831. By 1896, this new London Bridge was the busiest point in London, with 8,000 pedestrians and 900 vehicles crossing it in every hour. It was then widened by 4 meters, but subsequent surveys showed that the bridge was sinking, so the decision was made to remove it. The current modern London Bridge was completed in 1973. Moving on to the first deterioration of the Thames. As London grew and the city was built over time, open street sewers were constructed, and the primary function of these was to lead rainwater away from the streets into the Thames to prevent flooding. And also, before the invention of the toilet, human waste would be stored in cesspools that were emptied by the nightmen, and the content was carried to agricultural fields. However, by the 1800s, with the start of the Industrial Revolution, factories and gasworks would appear along the Thames, and these would release their byproducts into the estuary. And as the population grew, and the cesspools and later the toilets had to be connected to these existing sewers, so human waste would also enter the Thames. The summer of 1858 was a turning point. Then there was an extended drought, which meant that there was very little freshwater flow coming down from upstream, and the Thames foreshore would become covered with layers of industrial and human waste, up to 6 feet or 2 meters deep at places. To make matters worse, this buildup of the waste was also slowly baked by the sun. This was the event that the press quickly began to call as the Great Stink of London. Interestingly, there were a number of ideas of how to deal with the pollution. One of those was to dig a canal from London to Portsmouth and to cover over the Thames from Battersea to London Bridge. Eventually, decision makers settled on the idea to construct a new sewer system, for which Sir Joseph Bazalgette was commissioned to lead. The idea was that a series of intercepting pipes would be built to lead sewage away from central London and release it with the outgoing tide in the east. And then these intercepting pipes would be connected to the existing sewers so that the rain would dilute the sewage. The construction took place from 1859 to 1865, and in the process, the embankments were built to encase and conceal the pipes. This meant that the river was significantly narrowed down, and with that, the flow and the tidal range increased. One of the most visible examples of this encroachment is near the present-day Embankment Tube Station, where the steps of York Watergate is about 100 meters away from the Thames. However, this building of the foreshore was not the first, as you can see on this cross-section of the now Upper and Lower Thames Street. Today, the Thames is actually about a third of its original width. Nevertheless, the Bazalgette sewer system brought a temporary relief, especially that it was designed for the usage of 4 million people when the population of London was still 2 million. By the early 20th century, as the city grew and expanded, pollution from tributaries and smaller sewage treatment works also started to enter the Thames. And because the river morphology was changed because of the construction of the embankments, this pollution would also quickly flow back and forth to London with the tidal movement. Then during the Blitz, large parts of the sewer system was damaged. And following the Second World War, industrial activities also continued. Due to the combination of these events, the situation once again became severe by 1957, when there was no established fish population between Kew and Gravesend, and the Thames was declared biologically dead. And the Thames Survey Committee was asked to investigate the reasons behind the dire state of the Thames. And their investigation showed that while the water temperature went up by about 3 degrees Celsius, the levels of dissolved oxygen dropped, which significantly affected the Thames fauna. This is because there is a negative correlation between dissolved oxygen and temperature. So when water temperature increases, the dissolved oxygen level will go down. One of the main sources of this rise in water temperatures were the power stations. When power stations function, they would take on water to cool their equipment, and the heavily heated water would then be discharged back into the Thames. Later, the Pippard Committee examined the findings of the Thames Survey Committee, and they established that the estuary should support benthic fauna and migratory fish species. So with a large investment in sewage treatment works and waste disposal methods, the river quality was improved, and also the power station closed down. And in the subsequent years, in fact, within a decade, the fauna progressively returned, with flounder and the European eel amongst the first species to recolonize the Thames. And this takes us to the present. First of all, about the habitats in the Thames. Today, the main type of intertidal habitats are salt marshes, seagrass meadows, and mudflats. Mudflats are actually very rich with wildlife. This is where most of the invertebrate species can be found, which are, of course, a great food source for both birds and fish. And this takes me first to the invertebrate species. There are over 350 different species that can be found in the Thames. For example, amphipod, short crab, brown shrimp, river limpets, Baltic tellin, blue mussel, cockle, and ragworm. And moving on to the birds, residents include cormorant, grey heron, great crested crib, mallard, kingfisher, and some of the introduced species are mandarin duck, Egyptian goose, Canada goose, and the ring-necked parakeet. And in terms of fish, the cumulative number of fish species found in the Thames since its recovery is 125, with species like sea bass, Dover sole, flounder, smelt, and of course, the European eel. The European eel has a very interesting life cycle. They spawn in the Sargasso Sea in the southern Caribbean. Then using the currents, they drift across the Atlantic towards Europe, where they move into freshwater rivers through estuaries, and that is where they grow and mature. Then after about 20 to 30 years, they make their way back to the Sargasso Sea, where they spawn and die. Historically, eel numbers used to be much higher, as I highlighted earlier with the ear ends. But in the last couple of decades, we are seeing a significant decline in their numbers due to factors like physical barriers to fish migration, pollution, illegal fishing, and climate change. This is why the European eel now is a critically endangered species. In terms of the overall distribution of fish species, their presence will depend on whether they are freshwater or marine species and how much they can tolerate brackish water. And this is very much governed by how much fresh water flows into the estuary from upstream. So for example, during periods of increased precipitation, the freshwater zone can be pushed further downstream. Or during periods of drought, salty water can penetrate further upstream. This, of course, also makes the Thames Estuary an extreme environment for fish. I've talked about the source of mud in the Thames earlier. Mud is somewhat of a magic ingredient because it carries both organic and inorganic matter, and this makes the estuary a very productive system. And because of all these intertidal habitats and this magic mud, the Thames is a very important nursery area for fish. It is one of the only 5 known nursery grounds for Dover sole in the UK, and it is now the largest sea bass nursery area in southern England. There are also 7 species of fish believed to be spawning in the Thames. These are the roach, the perch, and the bream just above the Richmond half-tide weir, the common dace and the European smelt around Wandsworth, the sand smelt around Greenwich, and the common goby around Canvey Island. A few words about seahorses. Short-snouted seahorses do live around the British coastline, and several juvenile individuals have been found living in and around the Thames estuary too. Seagrass meadows are their primary habitat, so in the outer estuary. And the individuals that may be found close to London are those that were likely washed in by the tide. And of course, because of that connection to the sea, there are also sharks in the salty bit of the Thames. And just 3 examples: the taupe, the starry smoothhound, and the spiny dogfish. These species feed on small fish and invertebrates, and of course they are a very important part of the overall Thames ecosystem, so their presence shouldn't really worry us. There are also 2 species of seals in the Thames. The harbour seals and the grey seals can be distinguished based on the shape of their head and their body size. Harbour seals are smaller and their head and face is more cat-like, whilst grey seals are larger and their head and face is more dog-like. The 2019 population estimate for harbour seals was about 900 individuals, and for grey seals, it was about 3,200 individuals. And of course, they can be seen as far upstream as Teddington. Since the seal surveys began in 2003, there has been a clear and steady increase in both harbour and grey seal populations. If you are lucky enough to encounter a seal in the Thames or elsewhere, and you are with the dog, first of all, please put your dog on a leash, and then please be sure to give the seals their space, so don't approach them and move on without disturbing them. However, if you were to be approached by them, which of course would happen on their own terms, please leave them be, don't touch them, and wait for them to move on. A few words about invasive species. Within the entire Thames River Basin, a total of 96 invasive freshwater species were recorded between 1800 and 2010. And within the Thames estuary, the prominent species are zebra mussel, the Asian clam, the Kaga mussel, and the Chinese mitten crab. In the absence of predators, parasites, or competition, the populations of these invasive species can rapidly multiply, exhausting resources used by native species or severely degrading their habitats. And just going back to the intertidal habitats, so apart from them acting as a very important nursery and feeding grounds for fish and birds, they also provide important ecosystem services for us, such as enhancing biodiversity, improving water quality, food provision, and flood and coastal defense. However, as we slowly built up the Thames foreshore, large areas of these intertidal habitats were lost, and with that, these important ecosystem services also. Today, only about 1% of the Thames bank remain natural in profile. This is the 1.3 kilometer stretch at Syon Park in West London. To counteract this intertidal habitat loss, some of the riverside developments are now set back and vegetated areas are being created to enhance aquatic biodiversity. And some of these bioengineered intertidal habitats are collectively called estuary edges. We are at the Thames Estuary Partnership annually survey these sites and found that these habitats are functioning very well for juvenile fish like common goby, sea bass, and the critically endangered European eel. When it comes to conducting these fish surveys, so the way it works that when fish move through the estuary, they tend to move towards the edges. This is because the tidal flow is much more reduced there. And if there is a habitat, they will want to swim onto it. So first, during the rising tide in front of the habitat, we use a seine net. And with this long seine net, we do 3 or 4 sweeps and we separate out the fish found into buckets. And then we put down 5 nets, which get inundated by the tide. And once the tide starts to recede again, we recover them and identify, count, and measure all the fish we found for further data analysis. Moving on to plastic pollution. The sources of plastic pollution include strong winds, heavy rainfall, the tributaries, road runoffs, sewage outflows, and due to the shape and the morphology of the Thames, litter can accumulate at certain areas on the foreshore, creating so-called litter hotspots. And the plastic items that remain in the water column will break into smaller and smaller pieces over time due to the sun and wind action. It is estimated that up to 94,000 microplastics per second are flowing down the Thames through Greenwich at any given time. There is evidence of plastic in aquatic fauna. Microplastic pieces have been found in flounder, smelt, dogfish, and Asian clam. As I highlighted earlier, the buzzword sewer system that we still use was connected to the existing street sewers in the hope that the rain would dilute the sewage. And so it is no secret that during periods of heavy rain, the system overloads and sewage spills into the Thames. This has created a particular issue at Hammersmith, where a wet wipe mound was formed, changing the foreshore height by about 1 meter. So please, please, please stick to the three P's only when flushing the toilet. And just one more interesting thing about mud. Mud doesn't hold any oxygen, which means that whatever buries in it, it will be preserved. So objects like clay pipes, Roman roof tiles, pieces of beer mug, and occasionally a 5,000-year-old human bone can be found on the foreshore. This makes the Thames one of the greatest and largest archaeological sites in the world, and the objects found are continue to help piece together London's history. If you want to enjoy the Thames, you can actually walk it, you can cycle it, or even run it from source to sea on the Thames Path and the England Coast Path. And since I've just mentioned the occasional sewage overflows, I also must highlight that you can also paddle the Thames in various ways, but please do this via a club or an organized trip, and always check the weather, the tides, and familiarize yourself with the tideway code. I personally think that Londoners are very lucky, as London is a relatively green city with many parks, many open gardens, and we have a number of other rivers as well. And of course, we have the Thames on our doorstep, and by visiting it and exploring it, we can really appreciate its beauty. Moving on to the future of the Thames. So as I mentioned earlier, the buzzer-jet sewer system is a combined system. It collects both road runoff and household waste. And because the system was originally built for 4 million people, whereas there are now 9 million people living in London, during times of heavy rain, the system overflows. To remedy this, the Tideway Tunnel or London Super Sewer is currently being built and is expected to come online in 2025. This is designed to capture the sewage overflows and to store it up to 18 hours, and then gradually feed it to the treatment works. Once it becomes operational, sewage discharge from this old Victorian system should decrease by 90%. And with the building of the super sewer, open public spaces are also being created by the Thames, and some of these will also have vegetation which will serve as a wildlife habitat. Moving on to the climate emergency. So just to clarify the difference between weather and climate. Weather refers to the short-term changes in the atmosphere, so from minutes to hours to days, whilst climate is the average weather conditions over a long period of time, normally 30 years or more. The climate system itself has been studied by scientists since the early 1800s, and it was Charles Keeling who first started to directly measure atmospheric carbon dioxide in Hawaii, and these measurements now continuing at various parts of the world. And in terms of how the past climate can be reconstructed, so before the time when we had thermometers and satellites, scientists use so-called climate proxies, such as historical documents, corals, pollen, ice cores, tree rings, rock formations, and lake and ocean sediments. And this is how they can get an idea of the past climatic conditions. And so we know that the atmospheric carbon dioxide levels and temperatures have been following the same trend. And that in the last 10,000, but certainly in the last 2,000 years, stable temperatures and a predictable climate allowed us to settle down and engage in agriculture and to build our towns and cities like London. Arguments can be made that the climate has always been changing, and that is certainly true. However, our cities, houses, and infrastructure were designed for a certain climate to function well within a certain temperature range, not to mention the crops that we grow to feed ourselves. Data collected from around the globe show that in the last 200 years, atmospheric carbon dioxide has increased by more than 50%. And with that, the average global temperature has also been rising. In fact, data published this week on Tuesday shows that 2023 was the warmest calendar year since 1850. It was 1.48 degrees Celsius warmer than the period between 1850 and 1900. If you look at this graph again, you can see that actually carbon levels hardly reached 300 parts per million in the past 800,000 years. And these changes both in carbon levels and temperatures took thousands of years to happen, which allowed life on Earth to adapt. And just to provide a waypoint, the anatomically modern humans appeared around 300,000 years ago, so we certainly have no frame of reference when it comes to living in a world with carbon levels over 400 parts per million. So this rapid increase of carbon levels only in just 200 years or even less is what really worries scientists and puts us into uncharted territories. Focusing more locally, we can see this increasing trend in temperatures in the UK too. And of course, this is also affecting the Thames Estuary. There are increasing trends in water temperature both in the upper and the middle Thames Estuary, both during the summer and the winter seasons. Similarly, an increasing trend in sea level is also being observed, with a rise of about 4 millimeters per year. In addition to the climate proxies that I was talking about earlier and the real-time measurements, we can now also look ahead with the use of climate models that divide the Earth up into a series of grid cells, and so we can have an idea of what the future will bring in terms of climate change. And so projections show that the London area is particularly vulnerable for flooding, overheating, and drought. By 2050, London could see an increase in mean summer temperatures of 2.7 degrees Celsius, with some extreme weather, with less frequent but more intense rainfall, longer and more frequent heat waves, and extended periods of drought. And the winters are expected to become stormier, as we could see it in the last couple of weeks here in the UK, with high winds and heavy rainfall. This increasing storminess is the reason why the storm naming system had to be introduced in 2015. One of the reasons why these heavy rainfall events are occurring and will continue to occur around the world is because for every degree of warming, the water vapor content of the atmosphere will increase by 7%, and so the intensity of the downpours will also increase. And in terms of the extreme weather patterns, when we see days of very warm and very cold weather, that is due to the changing pattern of the jet stream. Under normal circumstances, which you can see on the left-hand side of the image, the jet stream would stay in place thanks to the pressure differences between the high and low latitude. But as the Arctic warms, this pressure difference reduces and the jet stream becomes wavier, which you can see on the right-hand side, bringing in either very warm air from the south or very cold air from the north. Sea level is also set to rise further. This is due to the melting of the Greenland and Antarctic ice sheets, and because the ocean is also getting warmer, and warmer water will expand, taking up more space. So we know that in the Thames Estuary area, we are already locked in for at least 1 meter rise by the end of the century, no matter how much we try to reduce our emissions. In addition to this, southern England is sinking by about 2 millimeters per year due to the post-glacial rebound following the last ice age. With more intense downpours in the future and the sea level rise, the prevention of flooding is one of the most important tasks set out by the Thames Estuary 2100 plan, which is an initiative by the Environment Agency. And this is especially important because 15% of London lies on the floodplain. And in terms of solutions, because there are solutions, there are two ways in which measures can be put in place. One is adaptation, when we prepare and cope with the change. And in this case, the example is sea level rise. For this, flood defenses are being put in place, being maintained, and being repaired within the Thames Estuary area. And the other type of measure is mitigation, when we help minimize the effects of climate change. One example for this is the creation of sustainable drainage systems, or SUDs, when we basically create more green patches around us to soak up any excess water, whether if it's coming from rain or flooding. And this, of course, can also help with reducing the urban heat island effect, as it is expected that London will see the number of hot days with maximum temperatures of 33 degrees Celsius increase during the summers. And another way of mitigation is, where possible, to create and restore habitats, for example, the creation of estuary edges, because these can help reduce the tidal flow and can reduce the impact of flooding, and of course can provide a habitat for wildlife. And there are also potential areas for habitat restoration within the entire Thames Estuary. By investing into both adaptation measures and mitigation measures, we can achieve what we call climate resilience. And in the meantime, we also have to be able to work towards achieving net zero. And that is it. I know this talk was a little bit dense, but it was really aiming to provide an overview and to create a basic idea of the Thames Estuary. But of course, there's a lot more that could be talked about. If you want to find out more, we have a story map, which we published in 2020 with more information about the Thames, and that is available via the link on the bottom. We also have a podcast series available on different platforms, and these individual series will unpack and discuss certain topics more in depth. We've also developed a course which is CPD accredited. This was the short version of that. And you can sign up to the long version via the link displayed there. And these are just some of the very interesting and personal favorite literatures that you can read to find out more about the Thames. I thank you very much for your attention, and I'm happy to try and answer questions now. But of course, you can also email me with any follow-up questions.
Thank you so much, Wanda. Somebody's just